All right, so we will start today talking about two things. First is I want to dive a little bit deeper into API requests. I know we talked about it a little bit last week, but just getting into some of the nitty-gritty details of what are all the different components of an API request. So hopefully you can start to feel more comfortable with them in general. And then also we'll talk a little bit about sorting and filtering, which is officially this week's topic, but we'll kind of talk about at a high level some of the different techniques that you might consider for these operations, specifically thinking about running them locally in your app versus using an API to do them directly. And of course, then we'll start utilizing both of these in our React blog that we've been working on and see these live in action. And as I said, if any other questions pop up that you have, just feel free to jump in. All right, so I have pulled a couple slides from last week just as reminders from our discussion. So as a reminder, there's a few different components that typically go into data fetching, right? We typically have some sort of API call through the fetch method, which is an async method from what we talked about last week. These typically live in a use effect because it happens outside the UI rendering cycle, so you have to throw into a use effect. It needs to be done async so it doesn't block the rest of the application. And you might need to pass in things like authorization tokens or other payload objects as part of that request, depending on what exactly you're doing. And we went through this example on the right-hand side of a standard practice of you have some state that you set up initially, you run the fetching, and then after you get the fetch request and the promise resolves, you sort of set the state with the data that you get back, and it will propagate throughout the UI. So pretty standard kind of infrastructure that we use for data fetching and React. Any lingering questions from this that we talked about last week? All right. Then the other thing I would just remind us from our discussion last week is a couple of things to keep in mind when we're working with APIs. First thing, documentation is your friend for APIs. Good APIs will have pretty strong documentation. So for example, the Airtable API actually I think has a pretty good amount of documentation. There's a screenshot from it that hopefully you've maybe referenced for your assignments. If you haven't already, you might want to take a look at that. And as we also talked about last week, we have different ways of sort of exploring these API responses, right? Whether it's through a simple console log of the response object you're getting or using these testing tools like Yak or Insomnia or something else to get a sense for what these response objects look like and what you want to extract out of them. And I'll repeat this again because it is very important for things like API keys, tokens, API secrets, we never will commit them to a repository because that's a security risk. You always throw them to an environment variable file .env, and you make sure that is included in your git ignore file so it does not get committed to GitHub and no one else should ever see it. Any questions on this high level guidance before you start getting into some new stuff on APIs? Hopefully this will all sound familiar if you were here last week. Okay, so let's keep moving. So let's take a moment just to talk in more detail about what are the different components of an API request. And so try to break it down here visually into the different components that you will typically see. So let's start with the URL, right? You're going to interact with an API through some sort of URL to hit the API endpoint. So let me take out my handy dandy annotation tool. So let's start with this request URL first at the top, right? So you can see there's these different components that you typically will see as part of an API request URL, right? You'll start with first some sort of base URL, which is, typically like for Airtable, for example, it's api.airtable.com, or it'd be, some other API endpoint typically. Typically, APIs then have some sort of version attached to it. So in this case, this is v0 that Airtable decided to call their API version 0 perpetually, but you'll see this quite a bit. Then we'll have some specific API path, which is specific to the endpoint we're trying to hit, right? So for example, This is the example of fetching something from Airtable. So we'll have what's the table ID and then what's the specific table that you're looking at inside of Airtable. And then you'll typically have a question mark. And then everything after a question mark would be what we call query parameters, right? So for example, it'd be things like sorting potentially could be an argument that you pass in, or maybe it's a search parameter. Like, hey, API, give me something that matches some sort of search query. That's the specific parameters would depend on the API and what the API supports, but the query parameters would be encoded many times directly in the URL after a question mark. And you can chain multiple of them together in one API request if the API supports that. So let me pause there. Any questions on sort of high level, what does the URL construction look like? This is relatively like the high level components I highlighted in the orange brackets are pretty generic across different APIs. So it's good to just get a sense and familiarity for like what are the types of things you'll see with these API URLs. No questions on that. All right, so let's move on to some of the other components of an API request. So those would be the boxes at the bottom here. So let's go left to right. So first would be the method. So again, hopefully this feels a little bit familiar to you, starting to work with these APIs. This will be the specific type of behavior you're trying to use from this endpoint. So they could be one of these are kind of pretty standard ones, get, post, update, delete. So again, on the back end, what happens is for a specific endpoint, you might have different behaviors based on different methods that you might want. So for example, in this case, when you hit the endpoint for an Airtable table, if you hit it with a get method, that means it will return back, the functionality will be fetching data from the table. If you try to hit that endpoint with a post method attached, then that's different functionality you will get from the same URL, right? In this case, will be for adding a new element to the table. Same thing with update or patch is also another one that's used, and delete as well. Because the same endpoint, you can give kind of multiple functionalities to just from the different methods. And again, which ones are supported is going to depend on the API and what's been implemented. And this is where things like documentation become very important to take a look through. So that's the method. Then we have headers. These are additional configuration attributes that you attach to the network request itself. So this is where you would, again, add things like we've seen, authorization. So if you're passing an API key, this is where you'll typically put it in a header. Content type, which will indicate to the API if you're passing any additional content specifically in the body, which we'll get to in a second, and what type of data should it expect. For example, should it expect a JSON object? Should it expect an image data file or some sort of other media or whatever it is? So that's just, again, an indication to the API what it should be expecting from the payload. And there's a bunch of other headers that exist out there. These are, I would say, like two most important ones to be familiar with at this point. What is a payload? Yeah, that's a good question. So payload, I mean, in general, the payload is considered to be anything that you're attaching to the request object. So additional information. So this would include things like, if you wanted to, I think you can consider sort of the bottom three boxes here, method, headers, and body, would all be part of what you would consider to be the request payload. So this is all this additional information being sent to the API URL. And then the URL then knows, or the API should then know that, hey, there should be a payload attached to this request. Then I will look through and figure out what's the method that's being requested, what the header is, what's the body, etc. So it's just essentially whatever you're sending up with the API request. So you can think of these bottom three boxes as being part of the payload. Great. And then that final component of the final main component you should be aware of is the body. So this would be where you would kind of send up additional information that you might need to send with the API request, right? So for example, in Airtable, if you're adding a new element to the table, this will be where you would send up the information for that new element that you want to add. You'd add that separately in the body. And again, you would pair it with a header that tells the request that, hey, you should expect some content of type. In this case, you would say probably a JSON object. And the important thing with the body is it needs to be sent like over the internet, right? So you have to encode it essentially as a string, and then the body becomes a string. And on the other side, the API, it will see the body, it's just a string, but you'll tell it like, hey, this content type actually is a JSON. So then it will on the other side then decode the string into a JSON object and then do whatever it needs to do. So that's why it's really important to pair it up together. And so hence why in this example I put like a lot of times the body will just be, we're just sending up JSON objects. You'll use JSON to stringify some JavaScript object that you actually have in your React app. Okay, let me pause there. Any questions on any of this? Hope you should, I think the goal should be to, you should all be comfortable with sort of all these different components and understand what their roles are because these are all very common components of working with APIs and being able to work with them more comfortably. Okay, I'm going to take that as everyone's feeling reasonably good with these concepts, which is a good thing. All right. So with that out of the way, let's talk a little bit about filtering and sorting. And again, I'm not going to sit here and kind of give you a spiel on how to do filtering, how to do sorting. I think you all hopefully have maybe seen a version of this before. I think we've like talked about it actually in the context of the blog application we've been working on kind of earlier on, previous weeks. You can read the assignment instructions. Hopefully, it should be relatively straightforward in terms of just you call array functions in JavaScript. I more want to take a moment to talk about the different approaches you might take to these sort of operations, data manipulation operations in general. So in general, there's going to be two options that you have available to you, right? The first is you do all these operations in your code directly, right? So you fetch all this data from an API or some other data source, and then you actually in your application do the sorting and the filtering yourself. Or the second option is you sort of like ask the data source directly to do the filtering and sorting for you ahead of time, and then provide you the data back in the specific configuration you've asked it for, right? So how do you think about which one to use? So I put down here sort of general principles to think about when thinking about which option you might want to go with. So for example, for kind of locally operating with these functions, this is best used when you're working with a smaller amount of data volume, right? So that you're not kind of like use up a bunch of performance, right, on your local machine. Maybe if you expect not as great network conditions, that might be a good choice to run these things locally so you don't have to keep pinging back and forth some sort of network request to say like, hey, I have this data, now sort it for me or filter it for me. So if you're worried about those network requests maybe not being consistent or performance not being great, maybe you just say, send it in one shot, the whole data, and then I'll take care of data manipulation. And also, it could be good if you're optimizing for, let's say, low latency feedback, or I said instant here feedback, but really low latency feedback, right? So for example, you might remember from our React blog, I sort of implemented two ways to do searching, right? There was like the one way of searching, which is I type in the search query, I hit the search button, and then the list updates, which I would consider to be like a higher latency feedback because you have to click a button. Versus we also implemented the ability to, as you type live, it live filters the data, which I would consider to be more low latency feedback. So maybe depending on which pattern you want, you might want to pick one of these or the other, right? So versus if you want to hit API endpoints for all this stuff, if you have large amounts of data, it might be a good idea to ask the server running the API to do that manipulation because some beefy server somewhere. So there are definitely cases where you actually would just need to do that because like a local browser would just hang if you just like try to do this stuff. Or it might be good to also, if you know there's some sort of like filtering or sorting that you know is going to need to happen on the initial data load, it might be nice just as part of the initial data request to just say, hey, data source or API, by the way, when you give me back this initial data, like also filter and sort it into some specific way. And then it just all comes in kind of one shot for free, right? As part of one data request. So that's also something else to think about. Okay, let me pause there. Questions on sort of thinking about these two options and how you might decide which option to choose in different situations. And I think the other thing I would just say, which might be obvious, is this option two on the right, what will be available to you will depend on what the API is implemented, right? If you're working with a third-party API, you need to look at, does this API support the ability to say, hey, sort by this or filter by this? Some of them may not. Depends on what's been implemented. So in some cases, you might just have to implement it yourself. If you happen to have access to the API itself, like you're working with a team that owns the API or you've written the API yourself, obviously you have control over what the API can and can't do. So obviously that's something else you have to take into account for all this. How should the data be for method two? That is a great question. I don't know if there's like a number necessarily, right? I think a lot of it will come down to like the data size. And here when I say data size, I probably mean like the actual like the number of like kilobytes or megabytes of data. So, I would say like maybe again, I don't know if there's like a good like cutoff. I would say if you're starting to work with megabytes of data, like I think that's definitely something where you start to consider, maybe move like doing stuff on the server side in terms of filtering and sorting. Also because kind of another tangent to this is let's say you have like a data set that's like megabytes and megabytes, or like you have a gigabyte of data, right? You probably don't want to download all of that gigabyte. You don't want to send all that data back to this to the app, right? Because that's a gigabyte of data. You're asking someone's phone or laptop to download a gigabyte of data, which is like not good if like they're not in stable network conditions, because then that might take forever. If they're like, it's just going to use a gigabyte of their data if they're like, on cellular or something. So that's probably not a good idea. So in that case, you would probably want to, right, like reduce the amount of data that's necessarily being sent to the client at every given point. So, again, is there an exact number? Probably not. I think for sure if you're working with like a gigabyte plus of data, absolutely. Like you should probably do this stuff on the API side, the manipulation before you send it down to the client. If you're talking about megabytes of data, I think I would still think about doing on the API side. I think for most of these applications that we're talking about here, like to-do lists or even like this blog data, is going to take a lot to get up to that much actual data volume because we're just working with text at this point. So you might, for a to-do app, for example, like this might be 1,000 or 10,000 to-dos is like when you would start to maybe seriously think about like you need to move this stuff to the API side. Okay, method one for what we're doing. Method two, pulling from existing API that might have a lot of data. I think like yes and no, right? I think to maybe what I was just saying. I think if you're working with a to-do list that has, because the other thing you have to kind of remember here, right, is like if you're working in like a production version of a to-do list, some like you might have a ton of to-dos, right? Like you might have, I don't know, over like a year or something, like you might add up to like 1,000 to-dos or something. It's like three a day or something. So even in that situation, at some point, I think you need to you can consider how you can be smart about doing stuff on the server side before sending it down to the app. So for example, like a simple example, right? You might say, hey, for let's say if you're just looking at like what to-dos do I need to do today, right? that's probably a place where it's smart to like instead of just asking the API for all the data and then doing any like filtering of like filter out all the completed to-dos and filter out only to-dos that are like due today. Maybe you just do that on the API side directly, right? I think because then you can only just get back like three or five elements instead of like 1,000 or 2,000 elements they have to filter through. So even in that case, like I think it all depends on the scale, right? Like yeah, if you're just working with like 100 to do elements, like yeah, for sure, you can get away easily with just downloading all the data and doing it on the app. At some point, it does become sort of necessary to think about that. And a very simple way you can figure it out is at some point your app's just going to become slow. And it's probably going to become slow because either you've done a network request that's like requiring large amounts of data to be downloaded, so therefore that's taking a while, or like the filtering and sorting is taking so long because it's such a large data set that it, like hangs your application, right? So you'll be able to figure out pretty quickly, I think, like at some point, like, oh, I need to optimize this performance. And the bottleneck is this stuff. Other questions on this? These are all good questions that you're asking. Just another example, like I would tell you, right, is my earlier point of this, it's more about kind of like the data size rather than like absolute number of like 10,000 rows or something. For example, if you're working with text data, there's not as much like data use like storage memory usage, right, with text versus let's say you're working with a bunch of image data. That's a lot of data. So, you know, let's say, just hypothetically, you might be okay with 10,000 to-dos to work with locally. But the equivalent version of that with, let's say, working with images might be like 50 images or something like that, right? Because each image is much more data heavy than, let's say, a piece of text. So all these different things that you kind of need to take into account as you're thinking about this sort of trade-offs here between these two options. Any other questions on this before we keep moving?
I would like to know, so if for instance you have a form which is populated with some drop downs and you have to select the drop downs, which probably you'll be doing filtering, but it goes back to fetch data from the API. Does that mean it's doing the first method or how does that work?
Yeah, so typically it would depend, right? So I think yeah, so if you have like some sort of like piece of like list of data with some of these filters or sort options and drop downs, there's
Yeah.
different ways you can implement that, right? So like one way to implement that is just as soon as you click an option, well, this first is like one decision point, which is do you want the data to filter or sort as you're selecting the options? Or do you want to select options and hit a button and then all the filter and sort happens, right? So that's like the first decision point you have to make, which will depend on specific application and so what might make most sense. And yeah, there's a second component, which is how do you do it? You could do it either way, right? You could do it based off of like, hey, whenever you either hit the button or you select a different element in the drop down, either run a local sort or filter function or hit an endpoint to fetch new data and then re-download it back, right? Again, like both of them will work, right? At the end of the day. In terms of like which one do you pick? Again, I think I would go back to sort of the discussion we're having here in terms of like what sort of data are you working with? How much of it are you working with? What sort of
Mm.
do you want to prioritize? Like, is your user going to have good network connections? Are they not going to have good network connections? Like all these different sort of components are what go into that decision of like which implementation path you take. but both of them will give you the same result at the end of the day, right? You will get your filter and sort functions on the data either way.
All right. Thanks.
Mhm. Any other questions? Great. So let's keep moving. And I think for this week's assignment, you will get practice with sort of both of these options. So you'll become familiar with sort of like, hey, how do you do each of them? So you'll be equipped to kind of utilize whichever one makes most sense in the future, right? Based on the situation. Okay. So I said I wasn't going to talk about the nitty-gritty details of sorting and filtering in JavaScript, but thought maybe we'd do an example together so that we cover that as well. So here's an example, right? So we got list of recipes. You can see on the left-hand side, I gave you kind of an example of what the recipe data object might look like. It has some different properties. And on the right-hand side, we have some function that where we get some data from an API somewhere, but then we want to sort it once we get the data back. So how would you go about implementing, in this case, we want to sort by the shortest time the recipe might take. So this num minutes property from shortest to largest. So then I want to take a stab at how we might kind of implement this ordered recipes variable. Does anyone want to, if anyone even has just like an initial thought of how they might get started with this, feel free to jump in. Okay, let me go back a slide uh, here. So I would say take a look at this, what I'm boxing right now, as maybe some inspiration. Sorry, that's a horrible box, but whatever this thing is I did on the left. Let's take this as inspiration. How would we use this to do the sorting? Any ideas? Okay, let's do this. Let me show you the solution and we can walk through it, and then just to get you kind of comfortable with what we're doing here. So let me clear this. Okay, so the most important thing, based on what I just highlighted, is there's this toSorted function that exists in JavaScript, right? Where you can apply that function on any sort of array of data, and then you can sort of pass in what sort of logic should be used to sort the data in that array, right? So that's the most important thing. So if we sort of take this example here, let me get back the annotations. So Specifically, we need to focus on this piece here, the blue bracket, right? So I've taken this recipe data, which I've gotten from this thing up here, which I've just like fetched from somewhere, right? Let's assume we hit some API and got this data. It's an array of some sort of data object that we showed before. I can then run this two-story function on it. I then need to tell it how should I sort this data, right? Because there's like an infinite number of ways you can sort the data. So the way you do this is you pass in an anonymous function. So you say, okay, if I take two elements from this array, we'll call them A and B here. I need to either essentially I need to tell it, does A go first or does B go first, right? Essentially in the ordering. And so the way it actually works is what you need to do is that those are denoted based on returning either -1 or a minus number or a positive number, essentially. So that's what I'm doing here with this return statement. So I'm saying for any two objects in this array, which have that data structure we looked at before for the recipe object, I want you to calculate what's compare essentially the num min properties on each of these recipes and then do some comparison, right? So if in this case, if you return a negative number, A should go first. If you return a positive number, then B should go second, right? So this is what you will use to tell it essentially what's the order. So in this case, I said A dot num min minus B dot num min, right? So essentially, because I want to sort it from shortest to largest, this is the expression I would use, right? So A dot num min would say, let's say if it's smaller than B dot num min, this would be a negative number, and therefore A goes first. And hence, that's why we kind of get the shortest ones at the front and the longest ones at the back. If we wanted to go in the other direction, I would flip it. So I would return instead B dot num min minus A dot num min. And then that's how I would flip the order essentially and go from greatest to least. So questions on that. And I'll just say it one more time because I realize there's a lot of moving parts there. So essentially what I have to say is I have to say, okay, for any two objects that you give me, A and B, in that order, pick A first, put A first essentially in the ordering if this expression I'm giving you is negative. Otherwise, put B first. And so again, then you have to define like what goes first when, right? So in this case, because I want the smallest value to go first, I pick this expression, right? If I wanted the largest to go first, I would flip it essentially. Questions on that? Because this is good to start getting comfortable with for sort of sorting arbitrary pieces of data.
Mm, Just a quick question.
Mhm.
When you're using the sorted function, does it return a new array or
Yeah, so that's a good question. So specifically, this toSorted function will return a new array in the order that you've defined here and will not change the original array in any way. It will preserve the original array.
yeah.
Now, there is enough. So this actually functions relatively new to JavaScript, relatively speaking. The traditional way of doing this would be to use a sort function in JavaScript, which does the same thing, except it not only returns a new array sorted, but it also sorts the original array as well, which you need to keep in mind or may not want, right, in this case. So in a lot of cases here, you will maybe it will depend. Like maybe you're okay with sorting data in place in the existing data structure. Maybe you just want to say no, put this sorting in a new data structure, depending on what you need. And so you can do that here. So in this case, ordered recipes is a brand new object, which is sorted, and we preserve the order of recipe data as it came originally.
Okay. Okay.
Mhm. And then just to be super clear, I think for the filter function, it's sort of the same logic, right? So filter gives you a new array, which is filtered, but preserves the old array as it was before. The only thing I would highlight here is I tried to demonstrate in this example illustratively, again, the typical structure of your code that you might see, right? Which is first you might fetch data from some data source in some way. Then you will probably do some sort of manipulation on the data. And then you will update probably some state you have with the data, and then it will kind of update your UI and propagate. And of course, then you would call this function in the use effect that runs just on the initial mount via the empty dependency array. So hopefully you've started to see the structure more, this kind of pattern more and more, and getting more comfortable with sort of applying that in your own assignments and work.
Okay, I think I get it. It's just the way it returns is messing with my head because I feel like there should be like maybe an absolute value or something somewhere, but it doesn't need that in this case.
And you're talking specifically about the sorting function, right?
Yeah.
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 Yeah, it is. I hear what you're saying. It is. This is a very long-standing architectural decision that's made on like how do you do sorting and filtering in code. This whole sort of
Oh.
like you return a minus number or a positive number. That's like goes back decades at this point in terms of that pattern. I agree, it's a bit nuanced. Let's say, let's call it. Um, but you will find like this pattern exists in pretty much any programming language, just kind of similar concept. So as you start getting more comfortable with it, you know, hopefully it will pay dividends even, if you do stuff later on.
Okay.
Question, is this a default sorting? Can you say more of what you mean by default sorting? Because I think here what we're actually need to specify here what sort of sorting we mean. I don't think there's a default sorting per se for this object, right? So just as a reminder, if I clear this and we go back to the data structure here on the left. This is just an arbitrary data object that we created, right? Which has like some ID, a name, number of ingredients, number of minutes. So there's no like there will never be like a default sort, right? Like JavaScript isn't going to help you, isn't going to be able to tell like how do you want me to sort this? Because you want me to sort by ID or name or ingredients or minutes? And do you want ascending, descending, some other sort of random logic that you might want? Like there could be an infinite number of ways that you might do it. So for these sorts of objects, you're going to need to define explicitly like what you want from this. And more likely than not, this is the sort of data you're going to be working with, right? It's sort of objects with multiple properties that can be sorted and filtered in multiple different ways.
Just I want to be clear when I read the documents like array, prototypes, sort, is it the default sorting it says. So just from that point of concept, how we take this example is what I'm saying.
Okay, I see what you're saying. Yeah. So I think by default, don't quote me on this because I've not looked in, I don't remember the exact details, but yes, I think if you were to give it, like if you were going to try and call this on an array of something, some primitive, like an array of strings or an array of just like integers, I think yes, if you call there's probably some sort of default sorting that's built into the function, right? So if I just called like numbers dot to sorted without this kind of function passed in, this probably, my guess would be the default sorting would be like sort it in ascending order, I guess would be my guess. But those would only exist for primitives, right? Like strings and just like integers, right? So in most cases, you're not, I mean, there will be some cases where you might run into that, obviously, but in most practical cases, you're never just going to sort an array of strings or an array of numbers. You're probably sorting some sort of more complex data object, in which case you have to supply some sort of explicit logic to sort or filter or whatever.
Cool. Thank you.
Mhm. Any other questions before we jump into some live coding? All right. And let's do some fun use of all this stuff. Let me share my screen. Great. Okay. Hopefully you all can see my screen. So I realized we talked for a little bit longer than I thought we would again today, but that's all right. So we have 15 minutes, so let's see what we can get through. I think the couple of things for sure I want to make sure we get through. One is, okay, we have, just as a reminder, I think everyone should be pretty familiar with this. Let me run the application. Okay. As a reminder, we have this blog, right, with all these articles. Right now, these articles are just living in a data object that's hard-coded in the code. So first, let's move all this data up into Airtable and load it from there. And then let's try to at least maybe implement sorting by these publication dates that we have currently. So ascending or descending. And then, yeah, I don't think we'll have time maybe for creating a new post. We will get to it next week then, because that is important to walk through as well. Okay, so let's first move the data to Airtable. So I, ahead of time, have kind of done this since it takes a little bit of time. So I've gone ahead. So just like you all have been doing this for to-dos, I went ahead and created a new table in Airtable. It has all the same fields just to match what we were using before in the JavaScript object. So it has a title, publication date, body, image URL, and author. And that's it. I have gotten the API key and everything. I store it in an env file. So that's all done. Okay, so that's done. We move the data to Airtable. Now let's fetch the data. So I'm going to go into my app and let's just fetch the data. So I have kind of pre-written low code here that we'll walk through. So here we have just a fetch articles function, which is async because we're going to call await and fetch. So inside the try block, I'm just fetching the API endpoint that hopefully you all are, this should seem familiar to you. And then I've attached the payload of this needs to be a GET request. I need to pass in the access token as well. Then once I get the result of this and I await it, I check to see if the response has an OK status. If it doesn't, I'm going to throw a new error. Otherwise, I'm just going to get the JSON of the response, again, to await that. And then for now, I'm just going to console out the data just so we can see it. And then I have this catch block. So if we throw the error, we'll know about it. And then I've just set up this use effect here, which runs on mount, and I just call fetch articles. So let's run it. So let me open up my console. And okay, so it's run it twice. So if I open up the object, records. Okay, so here's all of the these are the 5 articles that were in the Airtable that have come back through as expected with all of the properties that we want. Questions on this code? Hopefully it should start to feel somewhat familiar.
I think I have a quick question.
Hmm.
You mentioned about this to me last week about moving the function out of the use effect and then calling it in there to simplify like getting that constant variable message away. And I tried that, but then okay, I may have messed up the code, but then I got a new error saying that I needed to pass fetch articles the function into the dependency array. Do you know where maybe I went wrong, or I mean I had to look at it again.
Yeah, that is interesting. I think let's take a look at that separately because it
Okay,
might be specific to how you set it up, but we can take a look at that. If you have a few extra minutes after the session, we can talk through it.
cool. All right, let me
But to Melissa's point, she was mentioning sort of the structure which I mentioned last week, which is my preferred way of doing data fetching, which is all of the actual like, data fetching logic, I just throw it into a separate function and like call that async. And then I just like then call that function inside the use effect. I think to me this is like much cleaner, so you don't like make the use effect full of just random stuff, like all these like import.meta.envs and stuff, which just I think gets a little bit messy and is much easier to read. I think where you can say, okay, on component load, I'm just going to fetch the articles. Cool. And if I care about the details, I can then look at the function. Cool. So let's keep going. So we have this data, but this data actually isn't being shown right now because we're still actually showing this full article data that we hard coded. So let's first reset this data to be a blank array. So now should, there's a reason why that's not working. Uh, because of our search functionality down here, which we'll get to in a second. But let's go ahead and load this and say set articles to this data that we got. So let's actually like take this data and put it into the array. Okay, great. There's an error somewhere. We'd love to see. I know where the error might be. Yes. Okay, so there's an error. And it tells us articles.map is not a function. Does someone want to take a guess as to why this error is happening? It's a good thing that we came across.
Can you show where it's in the code in your article list component?
Yes. So yeah, the error is articles.map is not a function. So this is currently from when we are just displaying out the articles. And actually this will be in our, let's see, article list. So the error is being thrown technically here. So when we're trying to output this mapping, articles.map is saying it's not a function. And
It,
the change we made is that we just updated the article state to this data object from the response.
it's still reading your articles on your local device and not the
So,
API.
so I think that's been changed. And actually, just to prove that, I'm going to go into the hard coded data And I'm just going to essentially say export const dummy articles equals blank. So I'm going to assume that is now coming back as empty. So even if it was an empty array, I can still map over it theoretically because it just won't, there'll be nothing to map over, but it will still be able to say like dot map is a function on that array. There's something else going on here.
Is it because the data is inside a record? So we should do the data dot record?
Exactly. So if we look at these, how we are, so here, right, I was console logging out the data, which is, so the data object is an object, but it's not an array. It's an object that has a property called records. That's an array. So I can't, if I just write that, like this data object is not an array, and I'm just setting articles to to just this object. And so it's trying to call map on just a regular JavaScript object, which is why it's throwing the error. So yes, the correct solution is I need to make sure I actually extract out something from the data object that corresponds to that, which in this case would be the records property. So I would need to say, like, for example, now if I were to console log data.records instead, now you can see here at the bottom, this is actually now, this is an array. So now if I set articles to data.records instead, something's coming up. It's not looking very good, but something's coming up, at least. We're not getting the error anymore. Now, does someone want to, on a similar train of thought, does someone want to think about why we are now essentially not seeing any actual data show up in the UI? As a hint, I will say, keep looking at the data object that's coming back from the API.
You have to go into the fields and pull out the data one by one.
Exactly. So as you may or may not start to see, the structure of data you want in your application may not exactly align with the data structure that's coming back from the API. So you sometimes might need to do some work to do let's say, data translation between how the data comes back from the API and then how you want it structured in your data structures locally. So I like to maybe just do this separately in a separate line, right? So the data here is just like the raw data coming back from the response. In this case, what we actually need to do is we need to take data.records, and then what I would do here actually is I would say map this array, and for each object in the array, give me back r.fields. And then if I were to just store this in a variable called article data, and then let's go ahead and console log that instead. And so now if I refresh, okay, now it's an array. And this array now, if you look at each object, is, okay, it has author, body, ID, image, URL, publication date. So this is the structure we actually want. So now let me pass this in as the setter of the data. And now, okay, our data is showing up in the UI. Questions on that? This is pretty typical process that you go through to like figure out, oh, why is this not showing? It's because the API decided to return some specific data value in some weird way that I need to extract out and put in my own format. Most of the time, that's the situation. Cool. So one other thing I'm just going to call out here. So before, you might remember we implemented the search functionality. And as part of the search functionality, originally, we had said the way we're going to filter is we're going to take the full article data, filter on that, instead of filtering on whatever the state variable was. The state variable could always be filtered out. Otherwise, we'd just be filtering on the filter, and we just like not be doing it correctly. But obviously, full article data is like hard-coded data, right? Right now. So if I try to filter right now, actually, that's empty. So it like won't work, essentially, no matter what I type in. So this is broken. So just the way you get around that is you just need to keep some sort of reference to the full article data that comes back from the API and keep it separate from the data that you want to output visually. So it just means setting up a different state, right? So I, in this case, just set up, let's say, two states. So this all articles, which is where I would store the complete data set. And then articles would be whatever the articles I would show. So what I actually do here is I would say set all articles, because this is a complete data object. And then I would go here and set filtering from full article data, I would filter from all articles. And I could still use the set articles here because that's the state variable that we're using to power the UI. And then you'll notice, of course, here it's saying you're missing a dependency. So that's cool. I'm just going to add it because yes, all articles theoretically can change value. So now I can refresh this and try this again. Hooks, cool. Performance, okay. So we got our search functionality back. So just a small thing that we have to tweak because we're changing the way we're getting the data. Questions on any of that? Or clean up some of this code. Okay, so as a final thing, I know we're technically a minute over time, but just as a final thing, I just want to show you at a high level how the sorting might work here, right? So typically the way you'd set up a lot of times sorting is what some sort of drop down. So I've gone ahead and just updated and added a drop down, and I've added some simple scaffolding functions here. So typically the way this will work, right, is you would need to, your drop down will have some value. So right in this case could be ascending, descending, maybe. I need to store whatever is active in a state variable. This is sort of that control UI, control components that we talked about, that concept. So we're going to store the value in some state variable. We're going to attach that state variable here to the select tag, and we're going to hook into the onChange listener. So whenever we select a different value in dropdown, it calls this handle sort change, which then calls this function, which just simply updates the state to whatever the value is, right? That's been switched. And then to actually handle the sorting, you would just do it here, right? So after you, let's say, switch the order, then you would go here and actually do the array sorting, right? So for example, I'll just do it really quickly. I might say const sorted articles equals articles dot to sorted. And then I need to give it A and B. And let's just say we would sort it in this case by the date. So I would say return A dot publication date minus B dot publication date. Now I realize this might look a little bit weird. And why is this? Oh, I need some parentheses here. And now it says set articles to sort articles. So I need to actually update the UI. So now if I try this, and if I actually sort this, okay, it's not seem to work, which is lovely. So why is this not working? Let's see. That order. Okay, well, easiest way to fix this is to look at what's actually being returned. Okay. Let's see. So if I, okay. Okay, so it is sorting. Oops. Yeah, I was sorting. Okay. Not sorting correctly. And this is because technically we're dealing with strings. And so some programming languages can handle this function correctly. I think JavaScript has a different way of handling it, of sorting the strings. Just like any good developer, let's just Google it. So JavaScript sort string alphabetically, which will technically work here. Let's go to Stack Overflow, everyone's best friend. Okay, so this is what I thought would work. And I see. Okay, so, well, this is good to know. So JavaScript has a funky way of doing this. So this is a funky thing, as you can probably tell, even for someone who's doing this for a while. Everyone's got its own nuances. So there's this locale compare function that I guess JavaScript wants us to use. So now we actually try this. There we go. Now, okay, you'll notice it's actually doing it in the wrong order. And that is because this is probably in the, this is because we need to return different things based on whether it's ascending or descending. So what I would say is probably if the sort order is equal to ascending, then I would return this. Else, I would essentially flip the order. So I would switch the order of the two. So now, okay, I probably flipped it again. Okay, so sometimes you just gotta test it. So let's just flip again these orders. Okay, so there we go. So now it's descending in the correct order, ascending. It works now. All right. Any questions? I know we're over time, so if folks got to drop, feel free to leave. But any questions on that kind of speed run that a little bit?